Hello everybody, welcome to this third section about computer architecture and networks. We saw how a computer works, and how it executes programs. Now we are going to talk about network communication. So first let's see how information is transferred on a wire. Communicate on a wire, between a computer and a printer via USB for example, or between a computer and a phone. Let's see how this works. Well, technically, bits will be sent one after the other on the wire. That means the transmitter will have a certain number of bits in memory. It doesn't know what it corresponds to, but it just sends them one by one, and the receiver is going to receive the first, stored it in the memory, then the second, store it behind, etc. That's serial sending bit after bit. Sometimes, data is rather sent byte after byte. It depends on the wire and the technology used, but the principle is often the same. The different elements of information are sent one after the other. So to send on an electrical wire, each bit value will be associated with an electrical potential. For example, a 0 bit will be associated with a 0 electric potential, whereas a 1 bit will be associated with a 5 volts electric potential. So a voltage is applied on the transmitter side, through the wire, and the receiver is going to measure the voltage to understand if the bit it is receiving is a 0 or a 1 according to the voltage it measures. So the first question is, if the receiver sees a 5 volts potential for a millisecond, does it correspond to a single bit of 1, or too many successive bits of 1, one after the other? In this case, much like when an image coded in the memory is described, rules have to be defined in advance. To understand how the code is done here, an agreement has to be reached in advance between the transmitter and the receiver to say, if I transmit information, I will transmit 1 bit every microsecond. So when there will be a 5 volts value for 1 millisecond, that means there will be 1.000 bits, 1.000 times 1 microsecond, that went through the wire. Different kinds of wired connectors technically exist, and choosing one of them will depend on what the aim is, and also on what are the most recent technologies. So the important phenomena happening when transferring information on a wire are, the greater the distance, the more energy loss there is, because the wire can't be perfect. Some of the energy will get dispersed, will escape the wire, and so the signal's quality will deteriorate. Also, if the frequency is increased, so the number of bits that are sent successively, will also result in a loss of information, because some wires just don't withstand very well very tight and successive information sendings. So basically, the faster the data is sent, the more it will eventually degrade reception quality. So various kinds of connectors. Historically, the coaxial cable has been used a lot, which is what is most commonly called the cable by internet providers. It looks much like the classical TV antenna. It is actually a wire with a big insulation sheathing around it. And that cable is quite easy to deploy, well insulated, and that can reach great distances. But actually, nowadays, more recent technologies are used, like the twisted pair, which is actually a pair of wires mixed up with one another. Several of those are combined and are put in the same cable. In the picture to the right, there is an RJ45 cable, the commonly used cable to wire the computer network, and the telephone eventually, where there is a set of twisted pairs all put together inside the wire. That will allow information transfer on relatively limited distances, and in a way that does not necessarily support interferences very well, because it is not insulated as well as a coaxial cable, for example. So if that cable is laid in the kitchen next to the microwave oven, for example, there could be interference problems with the microwaves sent by the equipment. Nowadays, optical fiber is used a lot, so in this case, it's just a wire with the light going through it. So what's great with the optical fiber is that there are no electromagnetic interferences, so the signal will be carried out very well through hundreds of kilometers, or even thousands of kilometers. But it's a bit more costly and a bit more complicated to deploy, so that will be kept for great distances and for important facilities where the output needed is high, and to make sure everything works well. Technically, according to the distance or the output or the frequency of the data that goes through it, according to the tolerance to interferences that are needed, we will rather choose one technology over the other. But the principle stays the same. Bits pass one after the other, either with light or with an electrical tension. Wired communication is convenient, but it still has many constraints, in particular for its deployment, since cables need to be pulled inside the buildings, etc. The same goes for mobility, because when connected to the wire, it is harder to move around freely. Wireless technologies are very much used nowadays. This is a totally different technology. Electromagnetic waves are used to transmit information, so it can be television, radio, mobile phones, etc. The big difference is that a transmitter can broadcast to many receivers when emitting through a wire. Like before, there is only one receiver connected at the end of the line, and it receives information. When doing wireless communication, waves are sent and that actually spread so several people can receive it. That's a problem because you need to be able to send a message to a specific person, and to nobody else. Well, other people may be able to read it, even if they aren't the recipient, but the recipient needs to be identified from the beginning. So some addressing needs to be done, which means adding information to the message that says that message is for that person. Because of that, there are constraints imposed on network protocols. To finish, some orders of magnitude. The 4 left columns are about wired technologies, and the green columns on the right are about wireless technologies. We can see there is a huge performance gap. On the first row, that's network performance in megabits per second, and on the second megabytes per second. There is just a factor 8 difference because 1 byte is made of 8 bits. So you can see that between ADSL, what you have at home, which is about 20 megabits per second, and a modern, top-of-the-range optical fiber, where you can have up to 100 gigabits per second, the factor is 1000, so data can be transferred throughout the planet on an optical fiber much more rapidly than with ADSL between the internet provider and the house. The gap is smaller between the various wireless technologies. The big difference with wireless technologies is that the foretold performance and the actual performance will suffer great variations because that depends on the environment. With electromagnetic communications, if there are walls or other things between the receiver and the transmitter, the performance will get degraded because reception quality will get degraded because of these interferences. So technologies will have various degrees of performance, but performance will also depend on where you stand in relation to the transmitter. Let's take a few examples. Imagine you want to transfer a PDF document from the computer to a USB printer. Let's say the PDF weighs 100 kilobytes approximately, so a rather classic PDF will take a tenth or a hundredth of a second to send to the printer via USB. Transferring it via Wi-Fi or 4G to somebody else will take around the same time. Now transferring that file with an optical fiber will be much faster, a few microseconds, because the optical fiber has an enormous output. Now let's take another document, a full HD movie, for example, a few gigabytes, on an optical fiber, now that can take a second, or a tenth of a second, depending on the fiber's quality, etc. With ADSL, on the other hand, it can be much slower, the transfer will take several minutes, so that begins to show that it is less instantaneous. If you look at a more average use now, to use video on demand, for example, let's say full HD video streaming, so about 1 million bytes per second, a megabyte per second, with ADSL, if the connection is good, it should work. With a Wi-Fi and 3G network, on the other hand, it can get complicated, except if the reception is very good, so if you are standing very close to the Wi-Fi or 3G transmitter. It will depend on the conditions, but it could be complicated to watch high-quality videos on that type of connection.